Hello everybody. Last video I showed you how you can make your own pocket static generator. In this video I'll be showing you how you can make your own mini spark gap Tesla coil. You're going to need a 555 timer flyback driver, a high voltage flyback transformer, a voltage multiplier. Here is the inside of it. It is encased in oil. You need a small spark gap. Mine is made from 2 screws and a 3D printed body. You need a secondary coil and a primary coil. And lastly, you need a 12-volt power supply. I'm using an old computer power supply. Here we have our 555 timer flyback driver. It is connected to 12-volt DC and it is amplified by this transistor. You can use a MOSFET. Over here, the output is connected to the primary coil of the flyback transformer, and the output of the flyback transformer is connected to the input of the voltage multiplier. It's time for the primary coil connections. Alright, so here's the connections you need to make. So for your output, one lead will be connected to the spark gap. The other side of the spark gap will be connected to one side of the primary. And the other side of the primary is connected to the other output wire. And your bottom side wire of the Tesla coil needs to be connected to a ground bolt, which would need to be connected to electrical ground, which I'll show you. So I've got a wire in the ground of the outlet, and I'm running this wire and I'm connecting it to the screw. It's just connected right here. So here is the secondary coil. As you can see, the surface of the coil is shiny as I insulated it with a coat of nail polish. I did this to prevent any corona discharge. You can also see that to the lower end of this Tesla coil, there is some electrical tape and a small plastic tube is around that electrical tape, and then you've got the primary coil which is wound around that tube. That tube is there to prevent the secondary from arcing to the primary. You can also see that I have left some wire at the end of the Tesla coil, not at the output but at the end. This is to be grounded, and grounding a Tesla coil significantly increases its output voltage than a floating Tesla coil which is not grounded. You are also going to need a top load of some sort. Here I've used 5 hard drive disks stacked together and held together with the top of a hard drive motor. But really, you can use anything like a metal sphere or any metal object that doesn't have any sharp edges, as sharp edges promote corona discharge, which can reduce your output. Also, I'll be showing you the Tesla coil operating with and without a top load to see the voltage difference. Alright guys, now it's time for the fun bit. We are now going to attempt some experiments. So first, I'm going to show you the raw output of the voltage multiplier. Then I'm going to show you the Tesla coil operating with and without a top load. And I'll be also showing you some light bulb experiments. I'll be using a xenon tube, an incandescent light bulb, and a fluorescent light bulb, and see how the Tesla coil can transmit wireless energy. And there may be some other things. So enjoy. So I've connected this 555 timer circuit to these transformers. I don't think I mentioned this, but I linked these 2 transformers in series parallel configuration. I might talk about that later. But anyway, here's the output. So you can hear a high-pitched screech and some corona coming off my finger. This is the output. I haven't fine-tuned the frequency, so it's not the highest. Well, there is quite powerful. Alrighty, it's time for the voltage multiplier output test. This is quite loud and I don't recommend doing this, as yes, this may destroy your voltage multiplier. But I'll do it anyway. Oh, that's loud. It's going to be very, very loud. I don't think it's showing on camera, but that is very, very, very loud. Now it's time for the top load test. So here I've removed the top load, and I don't know if you can see, but there is a wire. It's not showing up on camera. But anyway, let's just run it. It's quite loud. But the output is not really that much. Alright, so I put the top load on and turning it on. It's already it's more powerful. Okay, so first is the light bulb. Next is this xenon tube. Alright. Next is this incandescent light globe. Alright, so I don't know much about this, but I can definitely smell it. After a few minutes of running, my room smells like this. What is this? This is ozone. So, I recommend keeping your room well ventilated or doing it outside at night. When operating the Tesla coil, make sure no sensitive electronic devices are in close proximity. For an example, I have this LCD temperature meter, and here I have a LCD screen which was exposed to high voltage. As you can see, all the crystals inside of it have blown up and turned into a black blob. This renders this device useless. The same applies to devices such as phones or computers, as they are more sensitive to the EMP generated by the Tesla coil. Now we have reached the conclusion of the video. My next video will be about the 555 timer flyback driver, so subscribe to see it. Also, if you have any inquiries or questions, do comment down below. It really makes me happy to see people are interested in my work. So, until next time.